Okay, so for this problem, you're given that the area of the inner circle is 40 pi. And so because of that, we know the formula for a circle is pi r squared equals 40 pi. And so we can quickly find out what the radius of that inner circle is. And it's just the square root of 40, which is 2 root 10. And so we can start off by knowing, okay, the radius of the smaller circle is 2 root 10. Well, that means, if you remember, the radius of the inscribed circle, the smaller one here, is the same as the apothem of the polygon. And so the apothem of this pentagon is 2 root 10. So now, if we draw in the radius of the big circle, which is also the radius of the pentagon, we can go through and find out what the side length of the pentagon is and the radius of the pentagon very easily. And so this would be x, and this would be r. We know our angle here is 54 because it's a pentagon. So we could say, to find r, we would say that the sine of 54 equals 2 root 10 over r. So that means that r equals 2 root 10 over sine 54. I'm going to go ahead and type that into my calculator. So 2 root 10 divided by sine 54 gives me r is equal to 7.817580303. So that is the big R. That's the radius of the big circle. And then to find x, we're going to say the tangent of 54 is equal to 2 root 10 opposite over x. And so that means x equals 2 root 10 over tangent of 54. So we calculate that, 2 root 10 divided by tangent of 54. And that gives me x, or half the side length, is 4.595058411. So to find the area of these, the first thing we do is we do the pentagon minus the small circle, which we know the area of the small circle is 4 pi. So it's going to be 1/2 the apothem. Remember, the apothem was the same as the radius of the small circle, so 2 root 10, times the perimeter. Perimeter is going to be this times 10. So it's going to be 10 times this x value. And then minus 40 pi. And that gives us the area inside the pentagon, but outside the circle, because we take the circle away. That's what the subtracting 40 pi does. But we only want 2 of those regions, so we need to multiply all that by 2/5. And then we do the same thing for this one, where we take the area of the big circle. The area of the big circle is going to be pi times the radius, which is this one, squared, minus the area of the pentagon. But the area of the pentagon we've already calculated. It's just right here. And it's going to be 1/2 times the apothem times the perimeter, which is 10 times x. And then similar to that one, we only want one of those regions, so it's just going to be 1/5 of that. So to simplify things, I'm going to make this 1/2 and that 2 go away because I equal 1. I'm going to do it over here as well. And so it's going to be on the first one here, I'm just going to do this whole thing. So it's going to be 0.4 or 2/5 times the square root of 10 times 10 times, now the x right now is the answer for mine, and so I'm just going to multiply this times the answer. That gives me, and then I'm going to subtract away 40 pi. And then I'm going to do the same thing, but this time instead of 2/5, it's going to be 1/5, so 0.2. And then it's going to be times pi. Remember that the radius of the big circle, I'm right here in my calculation, is that. So I'm going to have to type that in and square it, 7.817580303 squared, minus the area of that pentagon, which is just going to be the square root of 10 times 10 times the x value, which again is my answer. And then I work all that out, and I end up with 17.20. And that is the correct answer to this problem.